Okay, good morning, good evening, good afternoon, depending on where you are. Today is January 29th, and welcome you all to, um, to another hour of our bi-weekly SIG CLI meetings. My name is Maciej, and I'll be your host today. So a quick announcement that I would like to start with the meeting with is the enhancements freeze was due yesterday, which basically means if you're planning on working on any major features and the enhancements has not merged yesterday, then I'm sorry it won't be included in 118, but it's maybe worth working it out already so that we can land it in 119 timeframe. Another important date that is 5 weeks ahead of us is the code freeze. If my math is okay, we have about 5 weeks, five full weeks and a day to be specific before the code freeze. I do hope that this is sufficient amount of time for all of us to deliver all the 118 features. And from what I was checking, the tracked features for SIG CLI, it's pretty big. One last announcement, we held our first bug scrap last Wednesday. All the credit and the fame and applauses and everything else goes to Eddie. I'm not seeing Andy on the call today, but the gist is we went through a pretty big amount of bugs in the kubectl repo. We will definitely repeat the same exercise. And from what we were discussing, this will be held approximately once a month for starters. And eventually, as this list shrinks significantly, we will eventually reevaluate how frequently do we want to meet. I think that is all when it comes to the announcements, which means we can move on to the main topics. And the first one is Ahmed and Cornelius with crew installation issues. Guys, take it away.
Cool. Thanks, Maciej. Yeah, so this is a topic which came up in crew quite often in the recent months. So basically, how is crew installed? So crew, for everybody who doesn't know, crew is a package manager for kubectl plugins, and it does not come with kubectl itself. So we have a bash script on our landing page for crew, which is just, well, maybe not a one-liner, but it's pretty small to install crew. However, what we find is that people still want to have a more easier way to install crew on their systems. And in particular, people start adding crew to package managers, which in principle would be fine because it gives a consistent UX for installing binaries on the system. However, in the case of crew, it doesn't really make sense because crew is designed to handle itself. Crew itself is a kubectl plugin, and we don't want to give up control over when plugins are installed and in what versions in particular. Also, we found that some of those installations were not fully correct. So dependencies were missing and the crew installation was simply broken. So this is suboptimal for users' perspective because they would think that crew might be broken because the install completed successfully. And yeah, so also we don't want to maintain the adding crew to all different package managers because it would mean a huge overhead. I mean, I don't know how many package managers we would want to support, but there are a lot of them. And this is something we don't want and can do. So one option that we were thinking about was if we could get a shim in kubectl, which basically tells users that crew is not currently installed, but could install the crew itself on the system. So I mean, there are different variants of it. The most basic variant would be that just the installation instructions are printed. Then to various degrees, going to a full installation of crew. So what this would also mean is that the subcommand resolution would have to be changed for crew at least, because if this shim were really in kubectl, then it should only resolve to this shim as long as crew is not installed, which is different to other plugin resolution logic. Yeah, so basically it's halfway. It's getting crew halfway into kubectl. So not having crew completely in kubectl, but at least make it easier for users to install crew. Yeah, so I'm open for thoughts.
I mean, we could probably start with a simple suggestion. When you run kubectl plugins, we could check if crew is available. And if not, start with printing the suggestion, maybe with a link to where to get crew from or short instructions. How to get it. The reason that I'm struggling with the idea of installing is because when we created the plugin mechanism inside of kubectl, we specifically wanted to stay away. We wanted to stay away from the business of managing any kind of binaries, and I still think that was one of the best ideas that we could come up with back then. But I do agree that with the growing popularity of crew at this point in time, it is valuable to show users options that they have for managing plugins. And since crew is one of our main sub-projects for falling under SIG CLI, I think having that kind of a suggestion would be a good starting point. I'm not completely saying that we will never ever allow kubectl to install crew and then manage the plugins. But for starters, let's start with something simple and non-invasive, as in printing the instructions how you can get crew over there. Does that make sense? And I remember you just mentioned before, Cornelius, that printing suggestion is one of the options that you were considering.
Yeah, so printing the install instructions is yeah, certainly the smallest step in the direction of getting this into kubectl, but it's a good start, I think.
Okay.
Yeah, we need to see if yeah, if it really it reduces the need for people pushing crew into package managers, which I suspect will not work completely, because even finding the plugins command is not something which every user is aware of, I think.
So the other option is it would be worthy of looking through kubectl book and adding a chapter about managing plugins or working with plugins. So a combination of the book and the suggestion once you get to that point is a good starting point, and then we can reevaluate that situation once again.
Yeah, that's a good idea. Cool.
Cool.
Thanks a lot.
Sure. Thank you very much. Jeff, I see. Okay. I see that Jing Fang is on the call, but I'm not seeing Jeff, and he's the next one to talk about the kubectl trace option. Jeff, you're on the call?
Hey, that's actually me. I'll introduce myself.
Oh, sorry.
I'm David. I work at Google, and I usually work on node-related topics, although I dabble a little bit in... although I also work on some instrumentation-related stuff like cAdvisor and other things for node metrics. And one of the projects that I've sort of been working on and off for the past year is tracing, and trying to use tracing to figure out what's happening with controllers. And specifically, I like the kind of information you can get with traces, because you can see how the actions of different controllers in Kubernetes relates to what the user initially did. So I've threw together just a couple slides that I'll use to talk through this, but there's a KEP, and one of the changes that's required for it is a change to kube control. So I figured I would come and introduce it to you guys and answer any questions you have. So I'll start out. I was going to do a demo, but doesn't look like we'll be able to do it. Maybe we'll be able to do it in a few minutes. But there are two basic changes that are required for this. One is that the way that we propagate context to controllers is that we generate, when a user says, hey, please trace this operation that we're sending to the API server, one of the things we want to do is generate a context and store it in object annotations, because this is how we're passing the context between controllers right now. And that way, the controller manager, the scheduler, the kubelet, they can all reference that same trace context. And then when the trace backend gets all the traces at the very end. Is there a question? Let's see. No. And then when the traces get to the trace backend, that can then put them all back together into a nice trace. So that's the first change. The second change is that we have to send the context with the actual HTTP request that we make to the API server. This is sort of the standard way tracing is normally done, which is there's an RPC, you attach the context to an RPC, and it goes down the chain and then back up the chain, and you get a cool little trace like this. I split, for my demo at least, I split out the commit that contains the kube control changes out separately. So it's pretty easy to take a look at. But they aren't too egregious. If everyone else likes the way that we're doing tracing, basically the thing that we're missing without this would be that you can use client Go to send to trace operations, but then we really need a root of what the user input was. And so that's why we need to make a change to kube control so that users can specify when something should be traced and when it shouldn't be, if that makes sense. Okay. A little disappointing. There is also a KEP. I'll share the slides. I do a demo in my KubeCon talk last November. So if you're curious, you can go look that up. Yeah, unless something changes, I won't be able to demo for you guys today.
So I guess what I'm missing currently I've been following the progress of that particular cap.
Mhm.
But what other people might be missing is what's the end goal of, or how you want to, I don't know, visualize or make available for other consumers to get the information from tracing.
Okay, I could talk about that a little bit. So, and I can give a little bit of background. So with things like C-Advisor and Heapster, we took the approach of trying to have a community-owned component that could send to a variety of different metrics backends. And that has ended rather terribly since none of the integrations are supported, and it's a pain for all of the maintainers of those components. So I'm trying to take a slightly different approach here. There's a great new project called OpenTelemetry, which essentially allows us to instrument our components once and send to a what's called the OpenTelemetry agent, or it's also referred to as the collector. And that then can be separately versioned, and we don't necessarily need to have experts in the community for how do I send a Zipkin, how do I send a Jaeger, how do I send to whatever backend. We just need to send to this agent and support it in tree, and then you can actually get these traces in any backend you're interested in. So in my demo, I was going to demo with Zipkin, but I also have it set up with Jaeger and with Stackdriver. Let me see if I can just get a screenshot of what the trace looks like somewhere. Because that might be just as helpful as the demo itself, just to give you an idea of like what this does look like. Here we go. Okay. Let's see if this works. Okay, so here's me at KubeCon wearing the exact same outfit I'm wearing today. This is the trace, this is in Zipkin, and this is the trace that results from a deployment. So let me move this. So you can see, let's see if I can zoom in anymore. So you can see, can everyone see this?
Yeah, pretty much so.
Okay, so you can see that there's an initial request to create the deployment that we can see is traced in the API server and the etcd transaction that corresponds to it. But then once the controller manager picks that up and creates a replica set from the daemon set, there are other actions that are traced for that as well. The replica set creates pods, and then for each of the pods, we can see that they're scheduled, and then we can see all of the kubelet work down to the container runtime operations. And we can even see the final status update the kubelet sends to update the state of the pod to running. So all of that's in here. And you can get this, you can even see in my tabs up here that I've got a tab with Stackdriver, I've got a tab with Jaeger, and I've got a tab with Zipkin, because we are making use of the flexibility that OpenTelemetry gives us.
So I have a question once again. You already closed it, but going through the stack of the interactions, I've noted there was Kube API, etcd, which is going through API down, controller manager, which is controllers. But I'm missing, oh, there is Kube scheduler. Oh, okay, sorry.
Yeah. Sorry.
There is this scheduler. But I've noticed that the scheduler is less granular than the rest. Maybe that I could probably look a little bit more.
So this is a really flexible framework. The crux of what I'm proposing is that we can propagate context through objects, and then any controller that reads an object and does something in order to drive that object towards its desired state can trace their action. So what I've started out with, which I sort of consider what I've started out with is that I've traced almost exclusively RPC and HTTP boundaries. So you can see this deployment trace is created and ended when the request to the API server first hits the API server, and then when it returns back to the user. And the etcd transaction is when it's calling out to etcd, and then when etcd responds. So tracing along component boundaries allows you to figure out where a problem resides. So that's why I've started out with that. But you could certainly, if you were really interested in the depths of the scheduler algorithm, you could have multiple nested traces, or multiple nested spans instead of a single, hey, schedule this thing, if that makes sense. But any controller that can read an object can write traces about the work that it's doing on it. So this isn't necessarily specific to pods and deployments and replica sets.
David, this is Nick here. Thanks. It looks really interesting. Thanks for sharing it. Make sure I understand, is the ID associated with the interaction or with the resource?
So the ID is associated with, you'll have to define interaction a little bit.
So for example, if I say kubectl apply -f,
Yep.
is the ID associated with that event, or is it associated with the head of the tree of that resource tree that will be created as a result of that interaction?
So it is associated with the event. So this would be different than, for example, just using the object UUID and tracing and using that as the trace ID and just defining everything that happens for an object and all of its children.
So for example, if an operator decides to do something to a resource later on, I won't be able to trace those kinds of interactions because that isn't caused by a human?
Not necessarily. So what I've started out with has been, and for the demo, is obviously a user-driven change.
Mm-hmm.
But if you wanted, you could very easily have long-running processes like operators, or another example that's been thrown out has been like auto-scalers and things like that wait for a while and then take some action when it's required. Those can also all be associated with either the initial request that created those objects, but that may not make sense, or more likely, each time that controller decides to make a change, it'll actually decide whether or not to trace it within the controller, say with some probability. And then we can see some subset of the actions that controller has taken.
I see. And then I could imagine doing an outer join if I want to know all interactions that might affect an object. Maybe I could join it across the ID, the resource ID of the object.
Yeah, so one of the fun things about tracing is that it's an extremely rich format when you compare it to metrics or logs.
Yeah.
It does form a tree because it all has parent references, but it also has, in OpenTelemetry, they're referred to as tags, but for people familiar with Prometheus, you would think of them as labels. So you can say, oh, I want to find all of the spans or all the traces that it have spans that are related to an object with this UUID or an object with this name or something like that. And you would get a list of traces and be able to look at all of the spans that matched.
This was great. One other thing that came up recently for us is memory consumption.
Yep.
For example, so is that all in the scope of this, or is that a totally separate topic?
That's not particularly in the scope of this. I mean, there is an aspect of it since any of the components that export traces have a a buffer in memory where they buffer the spans that have been collected that are to be sent to the agent. So if you're worried about memory consumption in your component, then tracing makes that ever so slightly worse.
I see. But just in terms of knowing, for example, if my node capacity is at 90%, just being able to break down where that's occurring, another kind of trace, more of a heap dump kind of the, is that, it seems like that's a worthwhile topic of exploration. Is there anything being done there?
As in trying to figure out where, like profiling a specific application?
Or even profiling the cluster. For example, one of my colleagues has a totally empty cluster as far as he's concerned.
Yep.
But when he looks at top, it says that he's 50 or 60% utilized in terms of memory. Yep. And so that's a mystery to him, So just being able to peel back the covers there a bit, so there's a bit less of a sense of mystery and and intrigue.
Yeah, that's definitely. It's funny because I also am one of the experts in the community on the memory management system. So I can probably guess that not all of that memory, that most of that memory is reclaimable, but the Linux kernel chooses not to because it's lazy, right? So memory management is a hard thing, and we use a lot of heuristics.
Okay, maybe we should talk about that later. I think that's okay. Great, thanks. That's very good work, though. Thanks.
I mean, circling back, you're basically asking us as the SIG CLI for the approval of the -- trace flag for all of the create commands?
Create and update, so any write. It would also be nice to have it for get, since the idea is that I can actually, if a particular request is slow and I want to see the path it takes through the API server, the only thing I think we don't really want to trace is watch, since that is long running, and I haven't really reasoned through what a trace would look like or how it would be useful. I've implemented it for my demo just for create, but based on the structure of kubectl, it looks like it would be fairly trivial to extend it to other operations.
I mean, the only thing is figuring out the name, because I kind of hesitant on -- trace.
Yeah.
Might be slightly misleading, because some people might think that this is actually tracing the command, which is actually not true, but that can be worked out. And I think that I don't see any particular objection on having this kind of functionality. Unless anyone else have any objections, questions that they want to ask David?
Are there prereqs in my cluster? So do I have to have stuff installed for -- trace to do anything?
Right. So while this is an alpha, you'll need to have the feature gate enabled. Otherwise, you won't get anything. The other thing is that you do need to install the OpenTelemetry collector or agent, and that can be run in a number of different configurations. You could have it as a one per cluster service, or you can run it as a daemon set. In my experience running demos, especially on GKE, there are some tricky bits with how to get traces from the master. So if you have a master node that's stuck away somewhere, but that's a GKE problem, and we'll have to figure out how to solve that ourselves. So the answer is yes, you need to run a collector, and every controller that wants to be able to send traces needs to be able to have one of those collectors that it can send to. But once you have that, it's fairly simple to configure it to send to Zipkin or Jaeger or whatever your backend of choice is.
Okay.
Cool. I think that's it for me. Thanks for your time.
Yeah, thanks very much, David. That was very interesting. Does anyone have any final questions for David? Okay, moving on to the next topic. Thanks a lot, David, once again.
I can come back at the end if there's time and give the demo. It works now, so I'll come back.
Yeah, I think we have plenty of time, so go ahead and with the demo. I'm pretty sure that everyone are by now very interested in seeing that. I know that I am.
Let's do this. Sorry, I don't know why it took so long for me to get a shell, but here I am. So I have a pretty simple cluster running my stuff that I built a long time ago. I've got my edited kube control here. And basically the idea is I can odd if I specify -- trace, then I can hop over to Zipkin and I can see the same things I showed you before, right? The transaction sent to or the request sent to the Kube API server. I can get all sorts of lovely metadata about the request. I can see the gRPC transaction made to etcd and how long that took. And I can even see all the things from the kubelet and the scheduler. There it is. And back here, I can see the status updates that come through. So it's all there. And let's see. So something more interesting, like create a deployment, which you've already seen, but I'll show you again because it's pretty fun. Oops. Where do we go? So if I pop over here to my deployment trace, it looks exactly the same, except there's a whole bunch of them. So I think the structure of this is really fun because this is exactly how I would imagine thinking about how a deployment is created, right, across time, where I've got this tree of things and I can see sort of what each controller is doing. If I want, I can think about it in terms of time and realize that the kubelet is by far the slowest component in doing stuff. So you can see how the sort of hierarchical nature of it is very useful. And yeah, that's the demo. Cool.
Cool. Thanks a lot. That definitely helped. Okay, so I guess there are no questions, so we can jump on to the next topic. Eddie, I think you want to talk a little bit about our findings from last week. So take it away.
Yeah, David, that was an awesome demo, actually. That's really cool. My headphones aren't working, and I'm in a shared space, so I'm sorry if it's loud. Let me know. I just wanted to follow up. Did we make any decisions? So I think we're all in agreement that we need to get like the stale bot added to the kubectl project. Okay. Did anyone volunteer to take that on?
I haven't heard, and I haven't got a chance to work through it. So if you have the time and you're interested, yeah, go ahead. Just ping me in the PR or by Slack. That would be the simplest, because getting through the my GitHub emails is tough. So Slack is the preferred. Open a PR, and I think we can get it merged fast enough. But,
okay,
yeah.
Cool. I'll take that on, and I'll tag you so we get it done.
Okay, so to fill all that have not heard, so during the meeting last week when we were scrubbing the bugs, And I'm very sorry, everyone, because we did not record the meeting last time, but I promise we will, starting from the next one. We figure out that the bot that is responsible for closing inactive issues is not working in the kubectl repo, or we haven't seen it working. And we figure out and agreed, all of us present at the call, that we would like to have that one configured for kubectl repo as well. So Eddie is going to add that kind of functionality, or just configure, because I'm pretty sure that this is only about adding the kubectl repo somewhere in the test infra configuration, one of the test infra configurations. Eddie, one question. When we agreed to have the next bug scrub meeting, was it next week or the next after that one?
We said that we would do it monthly, so I figured we would do it a month from the last one, unless you think we need to do one next week as well.
Yeah, I think that's perfectly fine. So make just sure that you send out an email to SIG CLI so that people are aware that this is happening, and we need to work out a way of adding that one to the calendar, the community calendar. Okay.
Well, I'll figure out with Contribex or whatever how to get that sent out.
Cool. Thanks a lot.
And is that just for kubectl, or are we also going to do it for Kustomize and some of the other projects?
I would start with kubectl. Let's clean this one up. I've noticed that Jeff and Jingfan are doing a pretty good job with Kustomize, and on the crew front, Cornelius and Ahmed are dealing pretty well. I think kubectl itself is in the worst situation as of now. So once we settle on a good, as we figure out all the issues, that there's quite a few with regards to kubectl, we can sync with Jingfang and Cornelius and figure out where we want to go with the with crew and Kustomize. Does that make sense?
Sounds good. That's probably something good to include in the email.
Yeah. Okay. Cool. Okay. I guess that's that will conclude our main part of the meeting. Does anyone have any stand-ups or things that they want to share with us with regards to progress or stuff that they've been working in the past couple of days or weeks since our last call? Okay, I'll add on from my end. I'm trying to merge the removal of all the generators from under kubectl run. If you paid attention and tried to run kubectl run for creating deployments or stateful certs or basically anything except for pod, you'll probably notice that there was a deprecation warning. The deprecation warning was there for over a year. So based on the API deprecation policy, we are allowed to remove that functionality. And I have a PR in the queue that is currently waiting for an approval. And with good luck, it should be merged within the next 24, 48 hours or so. That's probably one of the main things that I looked at in the past weeks. Okay, I'm not hearing any other pieces for stand-up, so I guess we can close this call. Thank you very much for your attendance today, and see you in 2 weeks. Have a good one, y'all.